Okay, it says tree diagram shows the probability of a tennis player winning matches. The probability of a player winning their first match is 4/7. So here we go, 4/7. Easy. Now, that means that's got to be 3/7. You can either win or lose. You can't draw in tennis. Okay, it might even say that in the question. Right, the probability of the player winning their second match is 4/9. Okay, 4/9. 4/9. Now that means that this must be 5/9. Presumably they're a bit tighter on the second match. All right, the two matches are independent. So basically, what that means is that whatever happens in the first match does not affect the result in the second match. Now, in reality, that it might actually, but if for the point of this question, all right, the fact that it says it's independent means that the second match is not affected by the result of the first match. Okay, so complete the tree diagram, done that. What is the probability of the player A winning both matches? So winning both matches is this one. So win-win. Okay, so I've got to travel along here and then along here. Okay, now 4/7 of the time he wins the first match, and then of those 4/7, 4/9. Okay, you win those. So 16 out of 63. We multiply along the branches because 4/7 of the results are here, and then I want 4/9 of those 4/7. Okay, now then, next one, losing at least one match. So I want to do this one because that's win, lose. I want to do lose, win. Okay, now then, losing at least one match means I can lose both matches. So on this one as well. So I could do, I've got two ways of doing this, essentially, and I'm going to do, so the first one, 4/7 times 5/9. Bop, that's this one here. Oh, that's not very good, 7, there we go. 3/7 times 4/9. That's this one here. And then, what's the last one? 3/7 times 5/9, which is this one here. Okay, so we get 20 63s. I get 12 63s. And you'll notice I don't bother simplifying any of these. And 15 63s. Okay, add those up, we get 32, 47. 47 63s. Now, actually, I chose those two questions kind of on purpose because what I've got there is all the possible things. So this here, these two are all the possible outcomes. Winning both matches or losing at least one match is all the possible outcomes I could have, right? And you'll notice, hopefully, that 16 out of 47 makes 63. 63 63s is 1. So all of these probabilities down, here, all right, these ones here, okay, should all add to 1 as well. Okay, now sometimes you get different probabilities here, you get dependent events, but you just read the question very carefully there. All right, but if you set it out nicely, key is these add up to 1, these add up to 1, these add up to 1, these add up to 1. All right, quite simple, and tree diagrams just basically show you all the possible outcomes and the probabilities of each stage.